Astronauts to the moon.
10, 9, ignition sequence start. 6, 5, 4, 3, 2.
Welcome to reality.
What's going on, everyone? It's Jeranism, here with another video for you, the results of the Moonlight test. First, let me remind you that I am searching for the truth no matter where it takes me. And second, let me remind you to do your own research. Test things yourself. The purpose that I try to convey in every video I do is that there's nothing wrong with confirming things that we've been taught and told are scientific fact. If the Earth is a whirling, flying rock in space, our tests will prove it. So let's keep asking questions and demanding proof of the scientific facts that appear to be dogma. Blind belief is the worst thing we can allow. So get out there and let's prove or disprove mainstream dogmatic science. So first, my moonlight test on the full moon of March 23rd started off with my temperature gun and 2 identical ceramic plates, and also 2 books. Now, the plates were both approximately 68.5 degrees Fahrenheit. The books were 70.5 degrees Fahrenheit. I then checked just to make sure, and the freezer came in at 0 approximately, and the fridge at 45 degrees. So I was feeling good. Now, quick timeout here. I'm not claiming to be a credentialed scientist. Okay? Yes, I understand there are many things potentially wrong with my setup. If you see things that are fatally wrong, well, please tell me. But little tidbits or your temperature gun is only correct plus or minus 1 degree or any other nitpicking is not needed, not wanted. So go away. Turn off the video. Go do your own experiment. Enjoy yourself. My experiment showed me the results that for now will serve as the truth until I see evidence that proves that my conclusion was wrong. I mean, is my test perfect? No. Do I trust my test more than mainstream science for now? Well, yeah. Why, you ask? Well, because there are certain things that science has told me that they say they're facts, and I don't feel sufficient evidence has been given to prove to me without a question that those are indeed facts. I've gone over this before, and I'll touch on it a little bit at the end of the video, but for now, I just wanted to see if moonlight was in fact cold. So this is a map here of my front yard, and this map will be on the screen in the lower left-hand corner so you can kind of follow along with my testing. The deck is covered, and the roof kind of sits on top of those 2 pillars there. So where you see number 1, it is not covered, but number 2 is covered. You then go down a few stairs, and the walkway leads to my truck. And the night that I did the testing, the full moon moved in location from where you see the moon on the top towards the bottom. And for anyone interested, the compass has been laid over the screen as shown here now. So we'll now head outside, and you can see the full moon. As I stand out on the deck, the sky was about 80% to 90% clear that night, and next to the moon is Jupiter. Excuse me, sorry. It was to the right of the moon, so when we zoom in with our camera, you can see the moon looks very rocky and spherical. No, that's a joke. Again, just pointing out that the moon never acts as a sphere. It never acts as a sphere would unless it was self-illuminated. For example, on the Discover Epic images of Earth that we get from 1,000,000 miles away, there's a very clear hot spot, but we see no hot spot on the moon. And also the top and the bottom should be quite shaded, but they are not. So for me, the moon is very important, and I'll talk a little bit more about that at the end here. Now as we zoom in to Jupiter on the right of the moon, if you look very closely, you can see what they call the moons of Jupiter. Of course, these can't be seen with the naked eye, but with our camera, you can see them quite well. Now, a little plug for the camera that we have, if you guys are interested. And before 1,000 people make videos saying I'm doing this for money, which they will anyway, I'm recommending the camera I have for anyone looking for an easy-to-use point-and-shoot camera, and providing a link in the description where if someone wanted to click that link and purchase the camera, I'd make like 3%. Pretty cool, huh? If you'd rather Amazon keep the 3%, then you can just type the camera name into the Amazon search box and I get 0. It's okay by me. I do want to say thank you to the many people who have already used that Amazon link. Last month we made 72 bucks from orders, and that's awesome. So I can't say thank you enough. And to those who emailed me and said to just do me and stop worrying about the haters, thank you. I wish everyone saw me for who I actually am. Unfortunately, that isn't the case, but I'm learning. So I said my piece here, and I probably won't say it again. So if I ever give a link to Amazon, you do not have to click it. You do not need to buy a camera. There's no requirements here. And so for the haters, I won't be addressing you in the future, and I'll probably link to this spot in this video if I ever need you to hear the following. If you don't like my videos, if you don't like me, if you don't think exploring and challenging what we were taught is smart, if you think it's stupid, well, allow me to teach you something. This is very simple. So say I'm watching BS Detector. His video on gravity misconception is awesome, but if I don't like him, I can click unsubscribe. Easy, right? Or I can even click his name, and it will take me to his channel, where I can then click About. Then this little flag here has a drop-down menu where I can click Block. Now in this case, I actually like BS Detector, so instead maybe I'll click Message and send him a message that says, hey, awesome work, keep it up. Or if I'm on his video, I can just click the pause button, and then go up to the search box, and you can type in anything you can possibly imagine, whatever you like. So if you like Lawrence Krauss, then type in Lawrence Krauss Schools Christians. Then you can listen to Lawrence Krauss tell people how dumb they are for them to believe in a book, while he tells you things that he wrote in his most recent book that he learned from a book. Because something can come from nothing, you know.
What is remarkable is that to create stuff, it sounds like you need stuff. And to create stuff, and the conservation of energy, you would think, and this is what the argument is often used, conservation of energy means you can't start with nothing and have a universe with something. But what is amazing is when you add gravity into the mix, a miracle occurs, that a natural miracle. That gravity allows negative energy as well as positive energy configurations. And you can create, for example, two particles out of nothing. Now they have energy because of their rest mass. But if the gravitational field they're in is strong enough, the gravitational potential energy attracting them together is so strong and negative that the sum total of those two bits of energy can be precisely zero. And you can create those particles with impunity. And in fact, that happens, we think, near black holes. And in fact, it will happen in empty space. And so in fact, to create stuff, you don't need stuff. You just need nothing. And in this case, quantum mechanics.
All right, brilliant. Now back to reality. So if you're in the market for an awesome camera, we've had ours for going on 5 years. Still works great. You can find them used for like $250. It's the Sony CyberShot HX200V. Does full HD video, 1080 3D, does panoramas, 18.2 megapixel, has 60x zoom. As you saw, you can see Jupiter's moon, so that's between 365 million and 600 million miles. Wow. Believe what you want. Let's just say it zooms far, and it's got a Carl Zeiss lens, and it's all for about 300 bucks. You've probably heard a lot about the Nikon P900. Great camera, but you're going to pay about 600. I don't think you get 3D or panorama. The Nikon is only 16 megapixel and the Sony's 18.2. Sony is 40% smaller, 30% lighter. So anyway, I highly recommend it. Lastly, the little newbie temperature gun I'll be using is pretty sweet. And for 15 bucks, you can do your own moon experiment and prove me wrong. Let's get testing. So, the moon was high up in the sky, and you can actually follow where I'm at. On the map, it'll appear here shortly in the lower left. And there'll be a little star to tell you where I'm at. And you can also look at the approximate temperature in the upper left. So the plates were left outside for about 15 or 20 minutes until I started testing. I took my little temperature gun and shot the one on the deck first. And you'll see here that that one came in at about 51.5 degrees Fahrenheit. That was the plate that was in the shade, not in the direct moonlight. We'll come up here to the ledge and shoot the plate that was in the moonlight, and we get about 44 or 44.5. So already right there we see about, 6 degree temperature difference. I'm now shooting the side of the banister and noticing that it is significantly warmer than the top, so we're getting about 50 degrees on the side. I come back to, again, the plate on the deck. It is 51, shooting the deck here, also seeing about 51. I shot off in a distance and got about the same thing, 50, 51. Shoot the plate again, and we're at about 50 or 51. So from that, I went back to the plate again on the ledge here. That one is in the moonlight. Again, we're getting about 44. So I went to my truck. Again, you can follow along the lower left. The back of my truck is not in the moonlight, as you'll see I'm behind the truck. So when I shoot the back end of the truck, I got a reading of about 45. Again, this is just shooting the back of the truck. It has not been hit by the moonlight, or hasn't been in a little while. So that's 45. I'm now walking around the side of the truck and going to shoot the hood of the truck, which is in direct moonlight. And so when I shoot that, I get 39 or 40. So again, we're looking about 5 to 6 degrees difference. And we come around here to the back once again, and we shoot that. And again, we see the same thing on the back of the truck, about 45. So then I walked around the other side of the truck, seeing about the same thing, 45 along the side. So it was pretty clear to me at this point that certainly what was out in the elements was definitely colder. Now here I stood at this post, and just to show you an example, you'll see here the post. I wanted to test A and B here, the top of the post versus the side of the post. You won't be able to see it if it's too dark, but you'll see here I'm shooting the top of the post and getting about 40 degrees, and just by lowering it a hair, I get 45. So again, same about 5-6 degree difference. So again, the top of the post, and then just slightly lowering it and getting about 5 degree difference. So I thought that was interesting, considering you'll see the moon is supposed to be there. There it is. The moon was there, and I saw that A was definitely getting the colder temperature reading than B. Now then I started to think that, would this be the case even if the moon wasn't out? So I had to wait all the way until we had a new moon, which was just the other night. So I went out on the new moon, April 7th, 2016, and the night was much nicer than it was the first night that we did it on the full moon. It's not nearly as cold, so I hypothesized that the top of the railing would be colder than the side, but not by as much, slightly smaller difference. Well, sure enough, that is what I saw. So I shot the railing and was getting about 55.5 degrees, or 56, and then just by lowering it a little bit to the railing side, was seeing about 58, or a little bit higher. So this was showing me basically that it was not the moon that's causing the temperature difference, that it was the night, the elements, if you will, and any covering or any shade is going to make the item a little bit warmer. So I went out to my wife's car, tried that, read the side of the car, which came in at about 58 degrees, and then took it to the top and was getting about 54 and a half or 55. So this kind of clearly, at least to me, gave me my answer and the results of my testing. So, what is the test conclusion? What are the results? Well, if you ask me, it simply means that the moonlight is not cold. The night is cold, and items in direct cold air causes them to be cooler than items which are not directly in the cold. So if you want an example, when you're out during the day, well, the sun is very hot, which causes the air to be hot. And if you happen to be in the shade, so you're protected by the tree from the hotness, well, it's cooler because you're protected from the heat, which the same thing but opposite happens at night. It's very cold outside, and therefore if you're underneath a tree, it's going to protect you from the cool air, which means that underneath that would be warmer. Doesn't necessarily mean that the moon is giving us cold light. So I could be wrong. I remind you, don't trust me, do your own research. This test can be done a lot better. I'm going to try it with a parabolic mirror and a magnifying glass, and also something interesting, it has appeared to be that there are less clouds in the sky on full moons. Maybe you've noticed it, maybe you haven't. And less clouds mean it is cooler at night. The question then becomes, does the moon affect the clouds? So get out there and test. I don't know. I say be careful. I think we might be jumping the gun a little bit if we're all going to be saying that the moonlight is cold. Wow, 15 minutes sure does fly by, doesn't it? Well, be kind, don't lie, and open up your mind, because there's truth inside. This has been Jeranism. Till next time. Peace.